Right, now let's do an example to see how this ANOVA test can be applied into practice. Let's say I'm working on a research to study the effectiveness of three different types of hypertension medicines. So in order to do this, I design a research that has 10 people taking medicine A, another 10 taking medicine B, and the last 10 taking medicine C. Then I will record the blood pressure from these 30 people. Then I find out the mean systolic blood pressure of the three groups as shown on the screen. As you can see that there's difference between these mean systolic blood pressures. And now I want to know if these differences from the three groups happened by chance or because of the medications. And the ANOVA test will help me answer this question. So then I have my null hypothesis. Mean systolic blood pressure is the same slash equal for people taking these three meds. The alternative hypothesis is at least one group's mean is significantly different from the others. I choose the level of confidence for my test is 0.05. So for the first step, I'm going to calculate the overall mean of systolic blood pressure, which is just the summation of the three groups' means divided by 3, and I got 133. Next step, I'm going to calculate the sum of square between by the following step. So I'm going to take the overall mean minus the group A mean squared and multiply by 10. And I'm going to do the same thing with group B and group C, and I got 350. Next, I will calculate the sum of square within by the following steps. I'm going to take group A's mean minus the systolic blood pressure A1, which is the person 1 in group A. Then I'm going to square it. And then I'm going to do the same thing for the remaining 29 people. And then I add all of them together. So I get 915, let's say. Next step, I will calculate the mean square of treatment, which equals sum of square between divided by its degree of freedom, which is the number of group minus 1, and I got 175. Next, I will calculate mean square of error, which equals sum of square within divided by its degree of freedom, which is the number of sample. Here is 30 minus 3, which is the number of the group, and then I got 33.89. So now I am able to calculate F stat by dividing the mean square of treatment by its mean square of error, and then I got 5.16. At this point, I'm going to use the F table of critical value for zero point zero 0.05 level of confidence with degree of freedom 2 and 27, and then I got the critical value of 3.35. Then I can tell that the F stat is above critical value, which means I can reject the null hypothesis and conclude that there is statistically significant evidence at 0.05 to show that at least one group's mean systolic blood pressure is significantly different from the other. So statistically speaking, the differences of mean systolic blood pressure from the three groups happened because of the medication and not by chance.